In this next section, I'd like to explore another field in the TCP code bits called the urgent field. And this is actually paired with another field in the TCP header called the urgent pointer. So there's a 1-bit flag in the code bits field called the urgent flag. And when that urgent flag is set, that means we now need to look at another field which is typically ignored called the urgent pointer flag in the TCP header itself. So let's talk about those. So let's just assume that these flags did not exist. Let's say there was no urgent pointer field. Let's say there was no urgent flag. So let's just say, just like the slide said, there was no way to indicate urgency. So in this particular case, the sending application has got 14 bytes to send down to TCP, and for whatever reason, some of those bytes 4 through 9, are urgent information. In other words, it really wants the receiving application to pay special attention to those bytes. But the sending application says, oh, I wish I had some way of informing TCP about that. So the best I can do right now is just send all 14 bytes down to the transmission control block. Transmission control block will look at all of them as equal. It'll create a segment the best way it can, which in this case is bytes 1 through 11. It has no way of knowing that bytes 4 through 9 are urgent. The process knows that, the application, but didn't have any way of conveying that information to TCP. So then TCP sends that segment to the receiver. All of those bytes are run through the transmission control block and then go up the stack to the receiving application, at which point in time the receiving application says, oh, hey, there's some bytes in here that are urgent. I wish I would have known that. I would have done something differently had I known that. Now, fortunately for us, TCP does have a method to indicate urgency. So it's the combination of the urgent bit flag as well as the urgent pointer. Now, just like we saw in the previous video when we were talking about the TCP push functionality, I mentioned the push functionality was something that the software had to be aware of. Maybe it's an API, who knows how it is, but somehow the developer of the software had to incorporate into their code this knowledge of the push functionality. So if the software wanted to do that, it could indicate in the send call, this is important, push it, send it out right now. Same kind of thing is true here. The software has to be aware of urgent data and give TCP that urgency. And in addition, the software had to say, here's the urgent data, here's where it starts, here's where it ends. This block of data that I put in this section of the buffer is urgent. So when TCP is made aware of that, here's what TCP is going to do. So now keep in mind, TCP has been, we don't know where in the process of creating a segment TCP is right now. Let's say that before this urgent data came down from the upper layer, there were already some normal bytes, and TCP had placed those non-urgent normal bytes at the beginning of a segment. So maybe there's a segment that's already got 50 or 75 normal bytes in it, and now TCP looks at this buffer and says, oh, there's some more stuff here that's urgent. Okay, so what's TCP going to do? Well, he's going to take those urgent bytes, pack them behind the normal bytes, so he's not necessarily going to start a brand new segment just because these bytes are urgent. He's probably not going to do that. If he's already got a segment in partial creation, he's just going to take these urgent bytes and add it to whatever data is already in there. And now what he's going to do is in the header, he's going to set the urgent bit, which is in the code bits, and then there's that urgent field, that urgent pointer. Let's just take a look at that real quick here. Right here, back in this slide. So when TCP is made aware of urgent data, it will set in the code bits, it'll set this 1 bit right here, the urgent bit. And this urgent pointer here is a way of indicating where this urgent data actually exists. Now here's what's kind of the weird thing about the urgent pointer. You might think, and this is what I thought at first, and what a lot of people who are studying TCP are led to believe at first, that you might think, okay, well, if a segment was already partially populated, and let's say the first 50 bytes of that segment was non-urgent normal data, and now at byte number 51, we're starting to shove some urgent data in there. You might think, okay, well, the urgent pointer, that's what it's going to point to. It's going to point to the very first byte of where the urgent data begins. Well, that is not actually true. Let's go back to where we were. So the urgent pointer indicates via a byte offset where the urgent data ends in the current segment. Where it ends in the current segment. And it does not affect the creation of a segment. So like I mentioned, if TCP is informed that there's a bunch of bytes in the buffer that are urgent bytes, one might make two erroneous assumptions. One might assume, number one, that, okay, I'm going to create a brand new segment just out of that urgent data. No, that's not true. If there's already a segment that's in partial creation that's still being the process of filled out, we'll just take that urgent data and add it to the back end of the normal data. So that is very possible that might happen. Second wrong assumption a lot of people make is, okay, well, that urgent pointer is pointing to where the urgent data begins, and that is also incorrect. So let's just take a look at this. Now, this is the other thing that sort of took me by surprise. What happens, so now I send out this segment, it's got that urgent bit set, it's got the urgent pointer set showing where the urgent data ends. What happens when the receiving device gets that? I actually read some articles which were wrong, which said, oh, okay, here's what happens. So, let's say I'm the receiving device and I've already got 200 bytes of TCP data I previously received that's buffered. And now here comes in another 1,000 bytes. First 100 bytes, normal data, just buffer that with everything else. And then all of a sudden the bytes behind that, oh, it's urgent. Some documents I read said, here's what it's going to do. When it's actually time to send the data upstream, it'll set aside the data it received beforehand and take the urgent data out of band, out of order, and send that upstream. That is not true. It'd be nice if it did that, but that's not what happens. When a segment is received with the urgent flag set, the receiving process will, number one, take in the entire segment, right? We got to take it in all the way to the end of the FCS field in the Ethernet frame. So we got to receive that whole thing in. And now, TCP enters what's called the urgent mode state. The next time the upper layer application enters the read state, it will see that TCP is in urgent mode. So very important point here. The receiving device, the TCP process, it's not doing anything special with those urgent bits, with those urgent bytes. All it's doing is like holding up a flag, holding up a sign saying, hey, upper layer application, when you look at me next time, I'm in urgent mode. What does the upper application do at this point? That is application dependent. And this is the real weird thing. So really, this whole urgent data, urgent pointer, the TCP specification itself doesn't say what you're actually supposed to do about it. It doesn't affect the creation of a segment. It doesn't affect how fast that segment goes out onto the wire. And from the receiver's perspective, as far as the receiving TCP is concerned, the only thing it affects is he holds up this sign saying, I'm in urgent mode. And when the upper layer application sees that, it's up to the application to decide what he's going to do about it. So now, of course, if you're the application developer, it's wide open for you, right? I mean, maybe this is just one thing I thought of. I don't know if any application developers have actually done this or not. But one thing I thought about in theory is, maybe we know that the CPU is giving each application a little slice of time to do its job, right? So let's assume that we're talking about, I don't know, FTP or something. And let's say that normally the CPU will say, okay, FTP, you get 20 milliseconds to read data. One thought I had was, well, if FTP looks down at TCP and says, oh, TCP is in urgent mode, one thing it could do is maybe it could convey back to the processor, hey, you told me 20 milliseconds. Is there any way I could get double that? Because this guy down here is in urgent mode, I'd like a little bit more time to read data so I can get some more stuff. I don't know if any applications actually do that, but it's the sky's the limit. The main point is TCP does not indicate what happens with that urgent data. Just imagine in your mind TCP standing there with a sign saying, hey, application, I got some stuff here. I'm in urgent mode. That's it. And then the other thing that I didn't write into these slides is once the last byte of urgent data gets transmitted upstream, then he takes down that flag. Then he says, okay, I'm not in urgent mode anymore. Once again, you might be wondering, okay, well, what's the application going to do when he sees these not in urgent mode anymore? Who knows? TCP specifications don't state what the application should do or not do. So here's an example of that. Bytes from the upper layer application come in just like we saw before. They run through the transmission control block, and this time the sending application was actually able to indicate that some of those bytes were urgent, bytes 4 through 9, and now TCP is aware of that. So TCP creates its segment, and here's what I want you to notice. It sets the urgent code, and the urgent pointer, look what it's pointing at, byte number 10. So the urgent pointer, technically speaking, what it's pointing at is the very first byte of non-urgent data. So after the urgent data ends, it's pointing to the first byte of non-urgent data. So there it goes, and then it's fed to the receiving TCP, and all that TCP does on the receiving side is says, hey, I'm in urgent mode. Next time you read from me, I'm in urgent mode. It also indicates the last byte of urgent data, so it will tell the upper layer application of that. It'll say, hey, upper layer application, when you start reading from me, byte number 9, which is in buffer, AF32, that's the last byte of urgent data. Who knows what the receiving application is going to do in response to this? So the TCP urgent functionality does not cause the sender to immediately encapsulate bytes into a segment and transmit. It does not cause the receiver to immediately take all the bytes out of the buffers and transmit up the stack. For this reason, the TCP urgent flag is typically used in conjunction with the push flag. So this is what I've seen in my sniffer captures. When I've seen the urgent flag bit, pretty much every time I've also seen the push flag bit set alongside of it. Although that pairing is not required. They are mutually exclusive of each other.